So this problem asks us, says, I can identify the basic features of a rational functions graph, such as vertical asymptotes in behaviors and discontinuities. So the first thing we want to do is we want to graph this, just to get a sense of the graph. So if you got a fraction, we'll put 2x minus 1, 3x plus 2, x minus 5, all over x minus 5. Now, the minute I see a factor repeating, I know that that's going to be a discontinuity, so that's going to help me. So see how I had the x minus 5 in the numerator and the denominator? Those can cancel, so really it's not going to change the graph much. That's not, the only problem is you can't, remember, you can't divide by 0. These are some things to remember. So it's going to create a discontinuity right there. So, oh, I have a syntax error, so let me see what's going on. Oh, I have 2 parentheses maybe. So, okay, let's see. Oh, I forgot a parentheses right there. So typing carefully is really important. Checking your work is really important. Let's see if that fixes it. Still a syntax error. Wonder where it is. Oh, I used a minus sign instead of a negative. Ha! Okay, that's the syntax error. So now, also I'm realizing I still am back on the trig graph. So I want to use a standard window, zoom 6, because the standard windows are better for any other graph except the trig. Okay, so we're looking at this, and this is a rational function with 3 different sections. And that means it has 2 vertical asymptotes. Now, the first question is, where do the vertical asymptotes occur? Well, they occur here and here, right? So I need to estimate where this is on my x-axis and where this is on my x-axis. I can trace it to kind of guess. Notice if I'm tracing them on this first section, over here, the right section, and as I'm going up, right here, I see my x is negative 0.4, and then I go one more time, but I've skipped over to my second section now, and x is at negative 0.6. So I have to guess that vertical asymptote's between them. So I'm guessing x equals negative 0.5 is my one vertical asymptote. And I'm going to go and see what kind of invisible line divides this middle section from the left section. So again, if I'm looking here, my x is negative 0.21, and I'm still on my middle section. I'm still on my middle section. Still on my middle section because see my y's are positive. Still on my middle section. Even still on my middle section because my y's are positive. So I can't see the trace, but I know I'm still on my middle section. And here I am at x equals negative 2.9, almost negative 3. And I hit over again, but now I've gone down to negative, so that means I am on the far left section, and I'm at x equals negative 3.1. Somewhere between negative 2.9 and negative 3.1 is my vertical asymptote, so that's going to give me to guess negative 3 is my other asymptote. Okay, but there's another way to know if this is in factored form, or if you put it in factored form, the denominator, wherever this equals 0 is where weird things happen. So we could have predicted all this anyway. We could have said, well, where negative 2x minus 1 equals 0 will give me something weird, where x plus 3 equals 0 will give me something weird, and where x minus 5 equals 0 will give me something weird. And then just solved. So x equals 5, x equals negative 3, and then this one over here I'm going to need to solve. It'll take 2 steps, right? Negative 2x equals positive 1 divided by negative 2, so x equals negative 0.5. Okay, so look here. These two match up with what I found on my graph, right? So when x is negative 3, it means I'm dividing by 0, which I can't do. It creates a vertical asymptote in the graph. And when x equals negative 0.5, it makes this factor equal to 0. You can't divide by 0, so it makes a vertical asymptote in the graph. But there's also this one where x equals 5. We can't let x equals 5, but we already said that because it cancels here, that's where the discontinuity happens. If you look at your table, if you look at your table, notice that there's an error at x equals -3 because you can't, because when you plug that in, it creates that 0. But there's also an error here at 5, even though in the graph there's not a vertical asymptote. So that's actually your discontinuity. So that's actually down here, x equals 5. So you can tell because there's not an asymptote at x equals 5, but x equals 5 makes the denominator 0, and you can't divide by 0, right? So there's a hole in the graph, right? Now you could have said something else. You could have said, well, because this x equals 5 makes the denominator equal to 0 and these two cancel. There's a lot of things you could have said as far as how you know. But you need to give an explanation. And the last thing is, what's the end behavior? Now, end behavior is when you trace it to the far left and to the far right. So when you're tracing it, to the far left and the far right. So when you're tracing it to the far left, your x's are going to get smaller and smaller. So we're not paying attention to our x's. We know they're going to get smaller and smaller. We're paying attention to our y's. What's happening to my y's? I've got -4, now -3.9. Keep going. I'm getting bigger and bigger, right? -3.7, -3.6. But it's flattening out. So this is one of those horizontal asymptotes. It's getting closer and closer to a value. It's not going to go on up forever and ever. It looks like it's going to flatten out, and it looks like it's probably going to flatten out somewhere near x is -3. But we could check the other side too. So I'm going to go back to my standard window, and I'm going to check what happens when I go to the far right. Okay, so let's trace and go to the far right. Not all end behavior matches left and right, but with rational functions they usually do. They're horizontal asymptote. So here, again, our x's we know are going to get bigger and bigger. We don't want to pay attention to those. We want to pay attention to our y's. This is -2.3, -2.4, -2.5. So look, it looks like that's getting closer and closer to -3 from the top. So I think it's pretty safe to say that the end behavior of the function is that x gets closer and closer, y gets closer and closer to -3 as x goes to positive infinity and as x goes to negative infinity.